Okay, extra credit number 3, finding holes in rational functions. So here we have a rational function. First thing you want to do is you want to factor the numerator and the denominator. So factoring the numerator, let's see, what are we going to get here? -3, -2, x minus 3, x plus 1. Factoring the denominator, here we have a difference of 2 perfect squares. So we have x plus 3 and x minus 3. So now that we have it factored, we can now identify whether or not this rational function has a hole or not. So if you'll notice right here, we have a common factor in the numerator and in the denominator. So when we have something like this, that tells us that we have a hole in the graph. And so to find out where that hole is, you would set that factor equal to 0, solve for x. So we have a hole at x equals 3. Now why is that? Well, if I plug a 3 in here, I get 3 minus 3 is 0. And 0 times anything is 0. And then down here we get 0 times anything is 0. So what we end up with here is when x equals 3, we get 0 divided by 0. And remember, we cannot have a division by 0. Okay? That is undefined. So let's take a look at the graph real quick. Now I plugged in the function right here. You can see the function. Okay? And at x equals 3, there's a hole in the graph. So if I go to x equals 3, 1, 2, 3, and we go up to this graph here, there's a hole right here. Now you can't see it, but I'll prove to you that there is a hole in the graph in just a moment. Let's go ahead and find out what the y-coordinate is for the hole. Where is it located? We know the x-coordinate is at 3. Okay, and by looking at the graph, which just disappeared on me, we know that it's going to be up here somewhere. So let's find out where. So let's plug in 3 into the remaining function. So we have, after we take these out, we plug the 3 in, and we're going to have 3 plus 1 over 3 plus 3. So our y-coordinate for our hole is going to be 4, 6, or 2/3. So our hole is at 3 2/3. So to prove to you that there is a hole there, once we plug this in, if we press Control T, go to our table, and we go down to x equals 3, notice it's undefined. That means that the function does not exist when x is equal to 3. Now you might be thinking, well, shouldn't there be a vertical asymptote there? Okay, but notice there is not a vertical asymptote there, but yet it's undefined at x equals 3. There is a hole right there in the graph. Okay, so while we're here, let's go ahead and review how to find our vertical asymptotes. We do have one, and that's going to be located at the other factor in the denominator, so that's going to be at x equals -3. horizontal asymptote. Notice that our degrees are the same, so we put the leading coefficient over the leading coefficient, so y equals 1. And the zeros. Remember, the zeros are where the graph crosses the x-axis. So, to find the zeros, we would take the remaining factor in the numerator, set that equal to 0, so we have a 0 at -1. So let's make sure that these are all true before we continue. So we have a hole at 3 2/3 right in here. We have a vertical asymptote at x equals -3 right here. Horizontal asymptote at y equals 1. And the 0, where does it cross the x-axis? We have a 0 at -1. Okay, so let's see, where is it? Here we go. Okay, so here are your 3 problems. I want you to find any holes that exist. Make sure you give me the coordinate of the hole. Give me any vertical asymptotes that exist, horizontal asymptotes, and all x-intercepts. Make sure you give me the x-intercept as a coordinate or coordinates. And be sure to show all of your work on how you found these. Thank you. Have fun.